Hey guys, Mr. Wimp here again. Today we're going to talk about combinational logic basics. So we're not going to get too in depth here. We're just going to talk about standard AOI logic. Okay, and basically combinational logic means that we're combining different scenarios and seeing what our output would be. And so AOI, the first thing that we have is this AOI logic. It stands for three different things. A stands for and, O stands for or, and I stands for inverter. Okay, so we have an AND gate, an OR gate, or an inverter gate. And basically, what we're looking at this is, do we have a combination of 1 and 2? Do we have a combination of 1 or 2? And are we changing a 1 to a 2? Okay, or if you want to look at it digitally, we have 0 through 1. So AND would be 0 plus 1, OR would be 0 or 1, and inverter would be 0 to 1, or vice versa, 1 to 0. Just switches how it's changed out. Okay, so that's the basics: is AOI logic, and or an inverter. So when I say make something in AOI logic, we know that we're going to use and or an inverter. Now the three basic gates look like this. So we have an AND gate, and an AND gate looks like this, and you have two guys going in, one coming out. So if you have 0 and 0, oops, if you have 0 and 0, you have 0 coming out. Okay, an OR gate looks like this. So it looks similar to an AND gate, but it's kind of like a moon shape. You have two things going in, so it's this or this. We'll give you that. And then the inverter looks like it goes in, it's a little triangle, that's the bus, and then the thing that inverts it is a little circle at the end, and it comes out. So 1 turns into a 0. Okay, so that's the symbol for these. All right, so you have and, or, and inverter. All right, so from here, where do we go? Well, let's move down a little bit, and we'll actually take a look at these. So let's take a look at an AND gate. All right, so we know that an AND gate is like a half circle. It has two things coming in, one thing coming out. So here's your out, these are your in, like that. Okay, out and in. And what I like to say about an AND gate is, pretend you're wanting to go to the movies. So to go to the movies, you have to have a 1. 1 is yes. No movies is a 0. So if mom or dad say no, you can't go to the movies, so you're not going to the movies, that's a 0. If you do get to go to the movies, that's a 1. Okay, so the way I look at this, and you can find other ways to do this, but if you look at an AND gate, we say that mom and dad have to say yes to go to the movies in order for the movies to be a 1. So what that would look like is mom and dad both said yes to the movies. So mom and dad. So that means that you get to go to the movies. If mom said yes and dad said no, so there's yes to the movies, no to the movies. So mom said yes, dad said no. Mom and dad did not agree, so you do not get to go to the movies. And if mom said no and dad said yes, mom and dad did not agree, so you still do not get to go to the movies. So the only way to get to go to the movies is if mom and dad agree. Okay, that's the AND gate. On an OR gate, we'll use the same analogy, but this time we'll say mom or dad has to say that I can go to the movies in order for me to go. So if mom says yes and dad says yes, we'll do our OR symbol. Remember, it's like a half moon. So mom said yes, dad said yes. They both said yes, we get to go. So that's a 1. That's pretty straightforward. If mom says yes and dad says no, what do? Well, mom or dad has to say yes. Did one of them say yes? Yeah. So then I get to go to the movies. And if you did the other way, mom or dad, if mom said no and dad said yes, mom or dad said yes, so one of the two has to say yes, I would get to go. Now, if they both say no, mom says no, dad says no, well, what do you think? That's right. You do not get to go to the movies. Okay? So this is an output, that's an output, this is no output. So, and we have, they both have to agree, or only one of them has to agree. And then on the last one, the inverter is really easy because it's the opposite. So if there's only one person you're asking, if they say yes, well, it gets inverted to a no. So it's like opposite day. Mom said, yeah, go ahead and go. Well, guess what? That means that she's lying to you and says, no, you can't go. But if she says, yeah, no, you can't go, well, that means, yes, indeed, you can. So there's your I, inverter. Okay. Now you use the inverter to change states so that you get the pieces that you want over here. So we have AOI Logic. So let's see how that works. We'll do a simple min-term. The min-term will be our equation that we're going to use. And let's see, what will that look like? Let's do the AND gate again. So we like to use X, Y, and Z in this class, or A, B, and C for our 3 inputs. We usually do 3 inputs. So X is, we have like mom, dad, and brother, or 3 adults. Okay, in this situation we're going to use X and Y, or mom and dad. So here's X, here's Y. Okay, they go into our AND gate. We'll do AND. Okay, so they go into our AND gate, and we get Z as our output. All right, so basically what we can say is that Z is equal to X and Y. So X and Y equals Z. All right, and what a truth table would look like, we have X and Y. That goes down. We're going to make a simple table, and we actually have Z for our output. Okay, and if we look at this guy, basically you create your truth table, and every place we're going to mark out our truth table. So if X is 0, and we count in binary, so it's 0, 0, 0, 1, 1, 0, 1, 1. Okay, so if X is 0 and Y is 0, Z is 0. If X is 0, Y is 1, mom said no, dad said yes. You didn't have both of them. This one you don't have both of them. This one you do. So basically, by filling out a truth table, see, I can look at this and deduce that that's what that equals. But by filling out a truth table, let's change to green here. I know that that combination will give me a 1 for an output. So I can look at this and go, okay, well, Y, X. So X, Y equals Z. Okay, that gives me an output. So X and Y equals Z. All right, so if I have a OR gate, the OR gate works the same way, with the same truth table. So X, Y, and Z. We'll do our little tablets here. We have 0, 0, 0, 1, 1, 0, 1, 1. That's just binary. Now if X or Y is a 1, Y then Z will turn into a 1. So this one's 0. There's 1, there's 1, there's 1. So these 3 combinations, we'll go back to green, will all give me a min-term. Okay, so if I were to write this out, let's see, that goes to there. If I were to write this out, it would look like Z is equal to X naught, X is 0, so X naught, Y So there's that. Or, so or looks like this. It's a plus. Or, let's see, x, y, not, or x and y. Okay, so this guy right here is our min term. These are the ors. So x not y, or x y not, or x y will all give me an output for z. Okay? And then with the inverter, it's the exact opposite. So your truth table for your inverter, if you have x coming in, your z, if it's a 0, will be a 1. If it's a 1, will be a 0. Okay? So that one's real simple to do. Okay? So that's a real basic thing for AOI Logic. And in our next video, we'll actually do kind of an example circuit that you can take a look at. All right, see you next time.